Thank you. Thank you. All right. Well, thanks everybody. Really happy to be here today with you to talk about agent memory, one of my favorite topics these days. So just a little bit of background. I'm Chris Latimer. I'm one of the founders of Vectorize. But before that, I've spent many decades now at this point as a software engineer in technology. My background is engineering. And even today, I like to spend a lot of time in the weeds of the technology as much as I can. Lately, that's been a lot of AI research. We've published some cool papers out on arXiv on different ways of getting better retrieval. And more recently, published some research on agent memory. And that's primarily what I'm going to be talking about today. So to get started, let's just get this part out of the way. RAG is dead. It seemed cool at first. And I'll talk a little bit more about what I mean by that and why I think this. But maybe to start explaining, if we go back in time a little bit and we think about not that long ago, a few years ago, all we really needed was this LLM. We all had this kind of initial magical moment that you probably remember where you started using ChatGPT and you were like, write me a blog post, and all of a sudden it's like, wow, this would have taken me like all day to write this thing, and it came back, and you're like, that's amazing, until you've read it, and then it's a little iffy sometimes. And pretty soon we realize, well, there's actually a lot of missing knowledge in this LLM. The LLMs get trained, they don't know about our internal data. We need a way to connect our LLM to our knowledge in the organization, and so we needed some new patterns. And so the key pattern we invented, really Facebook invented, was this idea of RAG, of retrieval augmented generation, which just said, how do we take the data that we have, get it into a format where we can just in time retrieve that so that our LLM can answer questions and respond on topics that it wasn't specifically trained on. And it was a cool topic that we've all kind of grown tired of, I think, for a few reasons, right? So RAG worked well for really simple use cases. It worked well when what we wanted to do is load a bunch of documents into a database, look across those documents, try to find the right pieces and parts of those docs and pull it back. It was simple to understand. You could explain RAG, literally in like one simple diagram here. And it really wasn't too bad if all you had to do was search. But I've talked to so many people over the years who kind of started off with this basic RAG. And invariably what would happen is they'd roll this out to their users. And the user would say, well, hey, wait a minute. I asked the LLM, you loaded a bunch of contracts in. I asked the LLM, how many contracts are going to expire next month? It's like, oh, that's not really a good question for a vector database to answer just with semantic search. We need something more. Why did this thing happen? Why did this customer churn? I loaded all this information in. I don't know exactly why they churned. I needed more of a time series of events. And, which documents? So which documents in my long list of product docs talk about this? Well, RAG's going to give you back the chunks. It's not going to give you back an answer of documents. So there was a lot of work and a lot of sort of misconception between what we would be able to do with basic RAG and what people actually wanted to do when they used these AI applications. And then increasingly, what we found is the stuff that RAG is really good at are things that we increasingly don't need to solve for. We can throw a lot of these documents directly into the context window as they've gotten bigger, and we can kind of deal with these. So this has led, and this isn't really me saying, hey, I hate RAG. I don't really hate RAG. But if you kind of talk to enough people at meetups, you start to see this sentiment creep in more and more. And I think the better way of saying it is really RAG is just not enough. That's just not going, like the days of us being able to say, all I need is a vector database. I'm going to load all my documents into this vector database and off I go, are done. They're behind us. And this is especially true as we want LLMs to take a more active role in automation, as we want to move from this world of chatbots to agents. And we want our agents not just to think about the workflows that we put in front of it and automating a workflow that we define. We want our AIs to be able to figure out how to solve open-ended tasks. And in short, what we really want is we want agents that have agency. This is really a key point in terms of the definition of what an agent should do. And if you built agents, chances are that you've run into these 4 problems. These are by far the most common 4 problems I've seen as I've built agents, as I've talked to people who are building agents. Starting off with inconsistency. So you take your agent, you give it access to a bunch of tools, you set it loose on solving a task, and sometimes it does. Sometimes it's able to solve that task correctly, it figures out the right sequence of steps, uses the reasoning that it has, and it works fine. Then you try it again. And then the very next time, without you changing anything, because these models are non-deterministic, it doesn't figure it out the second time. So now you, as the AI agent developer, the AI engineer, you have to sort of figure out and try to, like, how do I get my agent to be more consistent? We still have to deal with hallucinations, right? So we'll give the agent context that it needs, and it still manages to misinterpret that sometimes. We still have to figure out, how do I make sure I get the right context back to deal with these blind spots that my agent's going to have? And then usually, like, through a combination of the first two, at some point you decide, well, I'm just going to keep pushing more information into this context window. My instructions are going to get more specific. I'm going to, every time the agent doesn't do what I want, I'm going to update the prompt. I'm going to give it better instructions. And I'm going to give it more context and more context. And before too long, you can end up in this world of cognitive overload, where the agent now just doesn't quite know what to do with all the information that you're giving it. And as a result, you get stuck. You'll see your agent start to go through these random walks of tool calls, trying to figure out how to complete a task. And eventually, you kind of hit that limit in terms of how many times you want your agent to loop through. And if we get down to it, a lot of these agent problems aren't really agent problems, they're memory problems, right? So from an inconsistency perspective, a lot of times what we have is our agent is not connecting the dots between the previous times that it has attempted a task or attempted to respond to a user to figure out, like, why it worked one time and why it didn't. There's no feedback loops here to actually create any sort of agent learning, right? You are the feedback loop. You're the one that's going through and saying, here's my prompt, I'm going to update that prompt. Hallucinations, oftentimes what we have here is really just insufficient retrieval. We're not grounding our agent into this semantic memory. And from a cognitive overload perspective, a lot of times what we have is these poor handoffs as we break down our agents into multiple sub-agents and as we pull back the right information. So this is the model that I like to think about when I'm thinking about the memory needs for an agent. I've got my current context, and I think about this in terms of, how do I optimize that context? This is how I think about context engineering. If I have an agent that's working on a task and it needs to understand the certain steps that it's going to take to solve this problem that we've given it, I want my agent to be able to understand where it's at, and this is kind of how we manage state. And then this is where I start to think about kind of the traditional replacement for RAG, which is more of a semantic memory, which may involve a vector index, it might involve keywords, it might involve graph, might involve time series, might involve structured data. And then we need to combine that with this idea of episodic memory. So what happened? What's the actual conversation histories that we've had in the past? What are the agent experiences? How is it attempted to solve things in the past, and what should it learn from those going forward? And then we need to feed these back into an ongoing mental model. We need to have the agent have sort of an understanding of its world that evolves and develops as the agent gets more experience. And so it was those sets of problems that kind of led me and my team to really start trying to solve these in a different way. And we ended up putting out a paper last month with the research partners that we were working with. Were at Washington Post. They were at the Sangani Center for AI and Data Analytics out of Virginia Tech. So we put together a research team, and we really tried to solve these problems. If you're interested in the paper, it links from our GitHub repo right here. So everything I'm going to talk about here next is all going to be completely open source. You guys can play around with it if you want. If you want to leave us a star, that would be greatly appreciated too. But we set out with a fairly ambitious goal. We said, how do we make agent memory that's going to work more like human memory? And so that made us think, well, how do humans form memories? We read a book, we don't remember every single thing we read. We can't repeat back verbatim all of the things that we learn. We remember some key points. And then the way we develop our understanding of a topic is that we think about it. We reflect back on what we read. We read more things, and then we start building on top of that. And so we wanted to think about how we could build a memory system that replicates this same sort of evolved understanding as we form memories and as new information becomes available. So we also ask, well, how do we recall memories? Well, sometimes recalling memories is very simple. It's just a simple, factual recall. If you ask me, hey, Chris, when does your daughter's school start? I'll say, it starts at 8. Really very little processing needed to be done. Just I memorized the fact that it's at 8. You ask me and I can sort of recall that. But if you ask me a more complex question, even one that's as simple as this, is the meeting you have tomorrow morning important? Now I have to access different parts of my memory. I have to first off know what does important mean? And then I have to have associations between the meeting. When is it? Who's it with? What are we talking about? And then what do I mean by important? I have to put all these things together to be able to answer that question. And then sometimes I have things that are the why questions often require causal links. They require me to understand a time series of data. Why did this thing happen? Why did you move to Colorado? Oh, well, I was at Google and I became a product manager and they said you have to be with the engineers and I didn't live near engineers, so I had to move. I have to sort of reconstruct the sequence of events that happen to be able to answer some of these questions. And then some things are just pure opinion, right? So if you say, is cereal soup? That's really up to you and my disposition of whether or not I think that cereal is soup or not. Some of you may, and you're wrong. So the way we decided to go about this is to say, well, let's separate memories out. We want to separate out the facts, right? So what are the facts that we know? What do we want our agent to root as? These are factual pieces of information. The user has told me that we have observed in our world as an agent. And then we want to separate those from the experiences. So the experiences are, what has the agent actually seen? If a user told the agent, I'd like you to go into my linear and close a ticket, and I tried to do it. I want to remember what I tried. I want to remember if it worked. I want to know if it failed. If it failed one time and worked another, I want to be able to understand how these things all fit together. So we need the agent experiences separate from the facts. And then what we want to do is we wanted to build a way for the agent to form a better understanding of the world around it. And that's what these opinions and observations are. So our opinions are ways for the agent to have its own disposition. So for example, if you have an agent that does bill collection and somebody says, oh, I'm in the hospital, we want that agent to form an opinion that's different than if you have a healthcare agent that says, oh, I'm in the hospital, right? One should be a little bit more skeptical of that than the other. And then the observations here are how we want the agent to now kind of look and connect the dots between these different memories. Yeah, you told me to close this ticket. I went to linear. I couldn't find the ticket. Why not? I didn't have the ticket number. So we want the agent to be able to form these observations to get a better overall understanding of the world around it. So in Hindsight, the way that we do this is by doing pre-processing on our memories. So we have these sort of two processing loops that you see here, or processing paths that you see here, memory processing and agent learning. So from a memory processing perspective, when new information comes into the system, whether that's through user interactions or that's through tasks that are being automatically attempted by the agent, we're constructing different representations. So we have traditional search representations. So we do use dense vector, sparse vector, or keyword search. BM25 is sparse vector. We use a graph structure. So we do entity extraction, and then we build links around those data. So we build entity links, we build temporal links, and we build time series, causal links between those. We'll take data and you can attach metadata to them. So if you want to do structured queries, you're able to do that too to narrow down your memory set. And then we have built this agent learning loop, which is how we're able to take the experiences that the agent has as it gets more experience trying different tasks, succeeding, failing, and then reinforcing that into this idea of a mental model. Now, from a recall perspective, we now have these different representations. And so what we do is we have a parallel retriever. So when you need to recall memories, one approach is not going to work the best for everything. You're going to have different questions where time series is going to work best. You're going to have different questions where graph is going to work best. And so what we do is we have a parallel retriever, and then we feed that into our reciprocal rank fusion and our cross-encoder model. And all this really does is it allows us to rank the memories that come back in relevance order that you can then constrain with a token limit. So you'll always get back, if you say, I want the 2,500 most relevant tokens, you just set your budget to 2,500 tokens. You'll get those back, and ultimately what you'll get is an optimized set of memories that's best suited for the request that you had. Now that sounds very complex, and the implementation is, but we made the interface very simple. So for you as agent developers, all you have to do is you have to know three things. We have a retain operation. This is how you tell the memory system, I want you to retain these things. We have a recall. This is just how you remember things. And then we have reflect, and that's how you build this agent learning loop into your system. And so with this, sounds good, but how does this actually work in practice? Well, it turns out it works fantastic in practice. From a long mem eval benchmark, we established state-of-the-art results, the highest performance ever on long mem eval. And these are things that are not just us saying this, these are independently verified results. These results have been reproduced by top academics at Virginia Tech. They've been reproduced by our research partners at the Washington Post, and it's going through the broader peer review process right now as we've submitted to the SIG-IR conference, one of the ACM conferences. And one thing I will say, as you're kind of looking at here, because there's a benchmark game, right? Vendors, there's no barrier to make claims about benchmark scores. I would always sort of recommend anytime you see benchmarks, you ask this question, like who reproduced this? Is this just sort of you making claims, or is this not? Just as a general practice before you sort of make any decisions based on that. So kind of tying this back to the problems that we have with agents, how does this actually help you as AI engineers go and solve your problems better? So when we take the feedback from agent interactions, we're able to make your agents more consistent. We're able to learn from those experiences. Agents will make mistakes, but what they don't do today is learn from those mistakes. And Hindsight fixes that. From a hallucination perspective, we make sure that what you're pulling back is always going to be the most relevant context that you can get, most relevant memories that you can get. And then we can reduce this down into a smaller set of tokens that you can feed into your LLM, which is going to ultimately allow you to improve that cognitive overload. And then over time, what you'll see is your agent will get stuck less. It'll just do a better job predictably solving the problems that you want it to solve as it goes. And the best part is it's completely free and open source. This is all, not sort of open source in name only. This is MIT licensed. You can go host it, steal it, change it, whatever you want to do. It's available here at this GitHub link. And it's also very capable. So it's not just sort of an API, you get the full UI. And I've got a table out here. If any of you want to see a demo afterwards, I'd love to show it to you. Show you like how agent learning works, how we set up the memory. And then we're trying to grow right now. So if you would be so kind as to visit the repo, leave us a star, we would really, really appreciate it. And with that, I'm almost exactly on time, but I probably want me to do a couple questions? Okay. Yeah, I'm going to come a little closer because I'm like half deaf.
How are you deciding, I just had it in my head, I forgot the question.
Oh, you need memory.
I'll have it again.
Anyone else? Okay, well, swing by the table. Let me think of it later. Go back a few slides?
Oh, yeah, you said from agent interaction. How are you deciding, what is a good interaction versus a bad one? I understand with, coding, you can see, did it compile or not,
Yeah. So the question is essentially how do we look at the interactions that happen? So what's going on here is that we have agent experiences. So the agent experience, when we store agent experiences, will kind of give the agent's point of view, which will include things like, was it just clearly a failure? I attempted to solve this task and it didn't work, right? Like the agent sometimes knows and it kind of gives up. Sometimes it will be, I have an experience if I tried this, I returned this to the user, but they gave me back feedback and they said, this is not what I wanted. And so what happens is when we do our reflection operation, we are kind of kicking off this part right here, right? This sort of agent learning part. And it's that agent learning where you're giving the agent a way to reflect back on its experiences and on those facts to say, like, the fact was, hey, I tried this and the API call failed, right? But my experience is I tried this, it worked, and the user told me it wasn't good. And so what we want to do is we want to use those to refine over time the observations that the agent has available to it so that it's able to come to those conclusions that you're hitting on.
So are you essentially just handing like a chatbot and saying
It's not just chat. So the question was like, are you just handing this to like the chatbot interactions directly, right? That's sort of it. So it's not limited to chat. A lot of agents obviously are chat driven, but even if you're building automations, right? If you're building something that is like, like personalized content based on like what the users, like what you're displaying on your website, or you're trying to automate some business process, all of those go into the agent experiences, and then you're building those feedback loops on there. So the more that there's sometimes you'll have more direct feedback than other times, right? But overall what you want is you want that agent to sort of take the aggregate set of experiences that it has and to form more concrete observations about how it should perform in the future. Yes? Oh, hold on, let me come closer. I really am going deaf.
develop some sort of like confidence scoring algorithm?
Yeah. So the question is there a confidence scoring algorithm? And yes, there is. So this.
Is that not the learning piece? Maybe that would be learning.
Sorry, what?
Is that not the learning piece then?
Yeah, no, it is. It is, yeah. So yeah, and it will. So the question is, are we using a confidence scoring? The answer is yes. There's confidence scores that are built in, because as an agent gets, like, we don't want an agent to over index on sort of like a single data point. So we want to have the more reinforcement that happens as the agent sees, like, this works, I'm going to now reinforce that opinion that this is the right way of approaching this problem, versus if I start to see things that are kind of mixed, right? I don't want the agent to get too confident, overconfident in what it's seeing. And then likewise, we built in recency bias. So as memories sort of fade and we have things that are farther back, if we get new information, then we want it to rely on that information. So like there's a AI project manager we've been working on, and one of the things why we built this the way we did is because we would see early on that like the agent would get confused when it's like, I looked at the meeting transcripts from last week and it says this task hasn't been started, and I looked at the meeting transcripts from yesterday and it says, oh, it was started, and I have conflicting information. So we basically built in this idea of bias, and then the confidence scores they don't exactly integrate in that way, but without going into the technical details of how that works, like we've accounted for both cases. Sorry? Confidential information?
Yeah.
Okay.
I mean like conflict information.
Oh, conflicting information.
Yeah. So do we need like a human to verify in this process during this evaluation? Like human confirm which one is good, not?
Yeah, there is detection of conflicting information that we have, but ultimately there's limits to what we can, like. It's just like when you do a merge in your Git repo, right? It's like eventually you know that you have this code and this code, and somebody has to make the decision of like how those things come together. So we do give you like the ability to come in and adjust the memory system as you need, because you probably don't just want you don't want us making some of those decisions for you. So you can adjust those. I think I'm over time. Okay, well, I guess I got a few more minutes if anybody has anything else.
I have a question.
Sure.
Do you guys do you intentionally do you support like intentionally forgetting or memory decay? And if yes, then how does that get decided?
We have the ability to delete memories, and so right now the answer is no, but very soon the answer will be yes. And it'll start off as just a simple time to live. Like it'll basically be it'll just be a, the like similar algorithm to LRU cache type of approach. We have some ideas for more sophisticated forgetting algorithms, which start to look kind of like a mix of like PageRank on Google, where the more we rely on a memory, like the less we should forget it. Like the longer we go without accessing that memory, like the less likely we are to need it, so that we can try to optimize for memories that are more important as opposed to just older.
So then, if the response from the memory is a correct or an incorrect response, so if the response is correct or incorrect,
Yeah.
what's the first thing that gets updated? Is it the confidence of formulating the response or the agent memory?
So the question is if it's correct or incorrect, like what actually gets updated?
Yeah.
Yeah, so the memory networks that we have here with opinions and observations get updated as we do reflection. So you sort of have the controls on the learning and like how fast it happens and when it happens by using the reflect operation. So when you do reflect, that's when you're going to update your memories, and that's kind of you're in the driver's seat on that one.
And would also store a context for the response, right? Or just
The context of the result, yeah. So like every time the agent does like interacts with the so there's a wrapper on top of the LLM, which is kind of the easiest interface. So you basically say, I'm just going to plug this memory layer on, and so it just intercepts the calls and it automatically does the connection to the memory system for you. And then what will happen is as that agent gets experiences, it's calling off to the retain on the experiences and calls off on retain to store off the facts. And so as it does that, that just kind of happens automatically, and then you decide when you want to do reflect.
And then, are there any use cases about evaluating different scenarios when retrieving information from memory? So, for example, I'm a hospital that has a certain set of rules that we are operating on
Mm-hmm.
guidance under. Now, I have to interact with somebody from a different state altogether. So, I'm in Washington. I'm governed by different healthcare rules versus California rules, for that matter. And I feed both of them to this LLM, and now I'm trying to understand the parallels and similarities before providing an unified output.
So, I mean, what we give you are kind of the building blocks, I think, for those type of capabilities. So, like, if I'm understanding the question correctly, it's sort of in the realm of like metadata filtering. I want memories to apply here, but not here, and I want to know when. We actually have a couple cases. We're working with a big gaming company who's kind of partnered with, without naming names, they do a lot of like movies, animated movies, and they have theme parks. So if you can figure out who that is from those clues, good for you. But the idea there is that they have these characters in movies, like AI characters. And the AI characters understand all of the movie world, like what happened, what was my experiences over here. And then when you interact with the character in the theme park, it has all the memories now of like the movie plus the theme park. And they've got a version online. So they don't want these things to cross, but they need like a common set of memories that are like grounded in all these contexts. And then they want to be able to limit the context based on like, am I in the theme park? And you sort of scan your little band there, and now it's got your memories of you. So they want to bring those things all together. So it's a similar type of use case, maybe a little like very different domain, but the same kind of idea there where I essentially want to limit the memories that I have. I want to share things across these different contexts, but I also want context-specific memories there. Oh yeah.
One small question, like you mentioned about the opinion, like what the agent believes in. How do you like make sure that the like confidence scores, like in a downstream task, how do you make sure that whatever the agent believes in is not like noise, or it's hampering the later steps?
Well, it's made so the question is like how do you sort of make the how do you have confidence in the confidence scores is kind of how to say that. Yeah. So the confidence scores are constantly adjusted, right? So like if all of a sudden there's counter examples, the confidence score will get lowered, and so you'll see it get reduced in terms of how how we pass the instruction along to the LLM to take that into account. It's based primarily on just the body of evidence that the agent has. So as it gets more reinforcement, right, the agent will either get more confident or less confident in its opinions. And so it's meant to be somewhat auto-correcting. As you get more information, the opinions get updated to reflect that information.
So it does have like all chain of thought, like its previous opinions also, and they keep on updating.
Mm-hmm. Yeah, exactly. Yeah.
One more.
Yeah, okay. Yeah, last one.
This is a less technical question. At the beginning of the presentation, you said that RAG is dead, right?
Yeah.
When I take a look at your website, right, and when I take a look at where there's a customer testimonial, and a lot of it mentions RAG. It's like makes RAG so effortless to set up.
Yeah.
Core part of our service is RAG. Building RAG pipelines has become so
Yeah.
So when you think about like moving forward, like in this next year, I guess if you had to like replace RAG, like what is the really simple way for you that you want to kind of describe what you see in this next year that your business is like focusing on? If RAG is dead, what is
Yeah, good question. So if RAG is dead, what isn't dead? So really the way that I think about this is here, right? Which is not so much that like, I think what's really dead is this idea that all I need is a vector database, and I'm going to load a bunch of documents in, and that's like my data strategy for AI. I think what happens is we end up in this world where we need to now think about our agents as having semantic memory. And the way that we access that semantic memory isn't just a simple vector index, embedding models that we build with maybe some metadata attached, but instead it gets into this world of I really need to have like different ways to retrieve my data depending on what it is that I'm retrieving. So I think the same approach here where we have different data structures for retrieving data and to be able to expose those in terms of like retrieval functions for like an agentic retrieval mechanism still applies. I don't think this goes away. I still think we need this semantic memory. I just think it becomes a question of like that's like this one part, right? And so I think the world of like, hey, I have a RAG application is dead, and now what I have is I have an agent that needs all of these types of memories if I want it to actually do something useful. So.
Is the innovation then like on this kind of feedback loop and confidence scoring loop then?
Yeah. So like I view Hindsight as like the first truly adaptive agent memory. I think everything with agent memory is going to be leaning towards this world of how do I make my agents evolve? How do I make my agents learn? And I think agents, once they become better at their tasks as they run, and your memory system becomes an enabler for like auto improvement over time, I think that's where like we go from this world of my agents are mostly automated workflows and innate in to the promise of the $1 trillion market a decade from now, which is I've got AI employees, they're handling entire business functions, they can handle open-ended tasks and figure it out and get better. Because if you're onboarding like a new employee, right, you're really counting on them learning things as they go. They have a big learning curve in the beginning, and they ramp up over the course of 6 months. And our agents don't do that, right? Our agents are like here's some better instructions in your prompt. And maybe it gets too complex and I start breaking things out, right? And I think the future is not that. I think the future is we write less prompts. We rely more on memory where the agent is now getting feedback and the agent is learning from its experiences. And that's how we get agents that learn and are able to handle more complex tasks. And I think that's all now driven by models getting better, which they've already gotten a lot better, and memory systems getting better. And I think that's going to be the key enabler for that future.
Active learning.
Yeah. I mean, I think you see a couple terms for this. Google's put out some research on this recently. Stanford and University of Illinois have put out research on this recently. Virginia Tech with us put out research on this recently. This whole idea of evolving agents, like how do we build agents that learn, they evolve, and that's kind of the missing gap. MIT published some research on this too. So yeah, thanks everyone.